Good morning, students. This is Usha from G.k.Jain High Secondary School. Today we are going to see the topic properties of matter in 11th standard physics. In this we are going to learn about the microscopic behavior of various states of matter and the elastic behavior of the materials. Let us move on to the topic. One of the oldest dam in the world is Kallanai, located at Trichy. The stability and utility of Kallanai Dam reveal the scientific understanding of Tamils. The other example known for insightfulness construction of the past is the pyramid in Egypt. The flyovers and overbridge are common worldwide today. Heavy vehicles play over and hence the bridges are always under stress. So without effective design and a suitable material, the bridges and flyovers will not be stable. Then we can talk about the technology. The material used for space application should be of lightweight but should be strong. The material used for artificial human organ replacement should be biocompatible. Artificial body fluids are used as tissue substitute for radiotherapy analysis in medicine. The fluid used as lubricant or fuel should possess certain properties. Next is macroscopic understanding of various states of matter. First we are going to talk about the solids. So in solids we are able to see the atoms and molecules are tightly fixed. So in the solid formation, atoms get bounded together through various type of bonding. So due to the interaction between the atoms, they position themselves at a particular interatomic distance. This position of the atom in this bound condition is called their mean position. Coming to a liquid, when the solid is not given any external energy such as heat, it will remain as a solid due to the bonding between the atoms. When you start heating, atoms of the solid reveal thermal energy and start vibrating about their mean position. When the solid is heated above its melting point, the heat energy will break the bonding between the atoms and eventually the atom receive energy and wander around. Here also the intermolecular forces are important, but the molecule will have enough energy to move around, which makes the structure mobile. Next comes your gases. When the solid is heated at constant pressure to its boiling point, or when the pressure is reduced at a constant temperature, it will convert to a gas. The process of a liquid changing to a gas is called evaporation. The gas molecule have either very weak bond or no bond at all. This enables them to move freely and quickly. So the gas will take the shape of the container and also will expand to fill the container. Now here the diagram, the schematic representation of the transition from solid to liquid to gaseous state with a change in external energy is shown here. So in solids, as we have discussed, so the molecules are very closely packed, and in liquids there is a little bit space where the molecule can move in that particular space, and in gases they are able to move freely as well as quickly. This is the solid changes. Substance can exist as a solid, liquid or gases. So when they get heated up, right, what will happen? Water exits in, the best example, water exits in three forms: as solid, as ice, liquid water and gaseous stream. So ice, water and steam are made up of same type of molecules, that is 2 hydrogen atom and 1 oxygen atom form your water molecules. Conversion from one state to another involves heating or cooling. So under certain conditions, some solids turn straight into the gas when heated. This process is called sublimation. We can give example as camphor. So burning of camphor will turn solid directly into the gaseous state. So solid, when we start melting, so they are being converted into liquid, and evaporation or till to the boiling point, we are able to get in the gaseous formation, and reverse is also possible. Next we are going to talk about the elastic behavior of the material. So If we consider a solid, there is an intermolecular force bind two or more atoms together and the atom occupy the position of stable equilibrium. When a deforming force is applied on a body, so what happened? The atoms are pulled apart or pushed closer. When the deforming forces are removed, the intermolecular force of attraction or repulsion restore the atom to their original position. If a body regains its original shape and size after the removal of deforming forces, it's said to be elastic, and the property is called elasticity. The force which changes the size or shape of a body, it's called a deforming force. And next one is plasticity. If the body does not regain its original shape and size after removal of the deforming force, it is said to be plastic body, and the property is called plasticity. Example, glass. Stress. When a force is applied, the size or shape or both may change due to the change in relative position of atom or molecule. This deformation may not be noticeable to our naked eyes, but it exists in the material itself. So, when a body is subjected to such a deforming force, internal forces developed in it called as restoring force. The force per unit area is called as stress. So, the formula is stress sigma is equal to force by area, which is equal to F by A. The SI unit of stress is Newton per meter square or Pascal. The dimensional formula is m L power minus 1 T power minus 2. Stress is a tensor. Now, stress is classified as longitudinal stress, another one as volume stress. First, we are going to see about the longitudinal stress. Let me consider a body, the diagram shown over here. When many forces act on the system, the center of mass remains at rest. This we have learned in our unit 5. However, the body gets deformed due to these forces, and so the internal forces will appear. Now let us consider delta A be the area of cross-sectional area of the body. Now the part of the body on the two sides of delta A exerts internal force. One force will take it as positive and another force will take it as negative. So we'll have F and minus F on each side, which is due to the deforming forces. The force can be resolved into two components as we learned. One is going to be the Fn normal to the surface delta A and Ft tangential to the surface delta A. The normal stress or longitudinal stress sigma n over the area is defined as sigma n is equal to Fn divided by delta A. In the same way, we are able to derive for tangential stress or your shearing stress sigma t over the area is defined as delta t is equal to Ft divided by delta A. Now, the longitudinal stress is further classified into tensile stress and compressive stress. First, we are going to talk about the tensile stress. Internal forces on the two sides of delta A may pull each other. That is, it's stretched by equal and opposite forces. Then longitudinal stress is called tensile stress, which act to the lengthwise, the changes, that is called as your tensile stress. Compressive stress, when forces acting on the two sides of delta A, right, push each other. Delta A is pushed by equal and opposite forces at the other end. So delta A is said to be under compression. The longitudinal stress is called as your compressive stress. Next is your volume stress. Volume stress happens when a body is acted by the force everywhere on the surface such that the force at any point is normal to the surface and the magnitude of the force on a small surface area is proportional to the given area. Let me consider a solid is immersed in a liquid. Then the pressure at the location of the solid is P and the force on each area delta A is F is equal to P into delta A. where F is perpendicular to the area. The force per unit area, it's called volume stress. Sigma V is equal to F by A, which is same as the pressure. Next, we are going to talk about the strain. So, strain measures how much an object is stretched or deformed when a force is applied. So, we can say that in one dimension, we consider a rod of length L when it stretches to a new length delta L. Then, the strain epsilon is equal to change in size by original size, which is equal to delta L divided by L. Epsilon is a dimensionless quantity and has no unit. And now the strain is classified into three types. One is longitudinal strain, another one is shearing strain, another one is volume strain. First, we are going to talk about the longitudinal strain. When a rod of length L is pushed by equal and opposite force, then the longitudinal strain is defined as epsilon L is equal to increase in length of the rod divided by original or natural length of the rod, which is equal to delta L divided by L. Now, in the same way how the stress is being classified into two, the same way here the strain is also, longitudinal strain is classified into two. One is going to be your tensile strain if the length is increased. Another one is compressive strain if the length is decreased. Next comes your shearing strain. So here the picture shown here. So you can see a cuboid. Let us assume that the body remain in translation and rotational equilibrium. Now we apply a force tangentially along AD such that the cuboid deforms as shown in the diagram. Now what happened to your shearing strain or your shear is epsilon S is equal to, what is the change? A dash divided by PA. Now as we all find out tan theta is opposite by adjacent. So we can write it as X by H. So as theta is going to be very small, tan theta can be taken as theta. So we have epsilon S is equal to X by H, which is equal to theta. So you will get the theta value angle of shear. Next is volume strain. Now the body is subjected to a volume stress. So automatically the volume will change. If V be the original volume of the body before stress and V plus delta V be the change in volume due to stress, then volume strain can be measured as epsilon V is equal to delta V divided by V. Elastic limit. The maximum stress within which the body regains its original size and shape after the removal of deforming forces, it's called as elastic limit. So, if we consider the deforming forces exceeds the elastic limit, the body acquires a permanent deformation. We can give an example for this. When the rubber band loses its elasticity, if pulled apart too much, it changes its size and becomes misfit to be used again. Hi students, you all have learned about the stress and strain in this chapter. We'll meet you in the next video. Thank you.